The data types can be classified into different types. Those are value sets, nets, registers, vectors, integer, real, time register, arrays, memories, parameters, strings. So in this we studied so many data types over there. In the previous class we stopped in the vectors actually, like how to declare a vector in a Verilog for a vector values. These are some examples we seen. So next we'll see the vector part select. In the sense, if there is a vector value, vector in the sense more than one bit. So from the vector, how we can select the scalar value? That is what I think what I can say vector part select. So here you can say the example here that previously mentioned, the bus. The bus is here, it has around 7:0. Example you consider like this. So the possible to address the bits or parts of the vectors I can say. Simple here bus A of 7. Example here we given bus A of 7. The meaning is what? The bit, the number 7 of vector bus A actually. Bus A may have n number of bits. Say example is bus A 15:0. In that I need to read only the seventh bit. If I want to read, you can take like this. Bus A of 7. You can access like this also. Same in vector. See the bus 2:0. You can access in this way also. So example I will tell like if I consider. See, for example is I will take like this. Vector part select. Vector part select. Example is I'll say bus A of 15:0. Now the part I want to access 7th bit value in the sense how can I access? One is I can access as like this. Only 7th bit I can access if you want access. Even if you want to access some group of numbers, even that also you can write. Say example, I want to access only the value as this. Bus A of 3:0. What is the meaning of this? The bus A has 16-bit value. In this, I want to access only the 3:0 value. Only that I want to access. Even you can do like this also. Bus A of 9:7. In part, in between also you can access. So the main is will be 16-bit. From this you can access like this. You can access however you want. Bus A of 14:3. Even I can access like this also. So this is the way how the vector part select can be accessed. So here we said. Then one more thing I said in the vector 2:0 or 0, but here you can see using the bus 0:2 is illegal because the significant bit should always be on the left of a range specification. Be remember here. So sometimes we may use like this. Even this also sometimes be correct. Now another example is virtual address 0:1. Here the two most significant bits of vector virtual address in the sense this virtual ADDR has 2 bits. Now let us select how the variable vector part select. So this is another ability that provided in Verilog HDL to have the variable part select of vector. See, this is the syntax actually. You can see there are two special part selection here, the operators. First is starting bit. You see here starting bit plus colon. What is the size of the value? That is width. The part select increment from the starting bit. You see, if I give like this, the string is like this, I give it. Starting bit. Example, I'll say like later. Part select increment start bit. Next, start bit minus. See, this is minus actually. Minus colon width. It is nothing but part select decrement from the starting bit. Here, I'm not going to give the like 3:0 is there. No, I'm not going to give in that way. I'm going to use in some other way. The starting bit of the part select can be varied, but the width has to be constant. Here, see, this width has to be constant here. So example, you see here now. Example, we consider this only. This is the very rare example register, that is REG 255 colon 0 data 1. The data 1 is a register which has 256 values. Okay, this is a little end day notation we can say. That is big end day notation. This one register 0 colon 255 of data 2. The data 2 has from 0 to 255. Next, the register 7 colon 0 is a byte. So byte is nothing but how many? It's 8 bit. So this is the one more register. Now let us use how we can access the variable vector part select with this syntax here. See, example I am going to say byte. Normally the byte is the 8 bit here. Right? As you know in the Verilog, when I am going to access some value, so left hand side must be equivalent to right hand side. Now byte is here 8 bit value. Now I want to access the byte from data 1 as well as data 2. How I can access? Simple. Byte is equal to data 1 of 31 minus colon 8. If I give, what is the meaning of that? You can see the stress there. What is this? The starting bit. See, remember, starting bit plus colon width. So here 31 is the starting bit actually. Minus colon 8 means starts from 31. Minus means you need to decrement how many bit actually? 8 bits. So I can say the start bit is equal to 31. The width is 8 actually. So it is equivalent to this. Data 31 colon 24. You see 8 bit will come. 31, 30, 29, 28, 27, 26, 25, 24. Total 8 bits. See, instead of writing like this, even you can write like this also. Variable part select. See, we'll see the second example. Byte is equal to data 1 of 24 plus colon 8. Now what is the meaning of this? 24 plus, it is nothing but it is an increment, correct? So 24 is the starting number, you need to increment of 8 bit. So what is that I can say? It is nothing but data of 31 colon 24, because you can see the total size of the data 1 is what? It is nothing but how much? Byte is equal 21 plus colon 8. I cannot write 24 colon, you may think why it is 31 colon 24, why not it is 24 colon 31? Because the data 1 is actually, data 1 is nothing but how it is given? 255 colon 0. So if it is 255 colon 0, it's going from MS bit to LS bit, right? 255, 254 like this. So I cannot go 24, 25, 26. That is the reason here they given us 31 colon 24. I hope you might have understood now. The reason is I cannot write 24 colon 31 here. Why? Because 24 colon 31 means it is like increasing. It is like a notation of big Indian notation. But the data 1 is a little Indian notation. Next, second is byte data 2 of 31 minus colon 8. So what is this now? 31 colon minus 8 means 31 is starting means minus, it's a decrement. But you may think 31, 30, 20. No, we cannot write. So because the data 2 is 0 colon 255. So simple, I'll say here how should not write, how to write in the sense simple. So this one actually data of 24 colon 31, it is wrong. We cannot write that. I given the explanation why it is because of 255 colon 0. 254 like this only will come, because here 24, 25, 26, no, it will become as wrong. Same the way. Second, here data 2. Data 2, what is data 2 of 31 colon got decrement 24. If I write like this, so even this also will be wrong. The reason is here it has come from 0 to 255, 0, 1, 2, 3, 4. So it has to here, if I write 31 to 24 means 31, 30. So it becomes wrong. The index position will get changed. So that is the reason here we written. So it is equivalent to this. Same here next. Data 2. You see the data 2 here. Data 2, 24 plus colon 8. Now simple we can say 24 plus means it's the incremental. So data 24 colon 31. Now you might have understood how we have to write the variable part select. Now one more thing you can say, the starting bit can also be a variable sometimes. Starting bit, this one. So the width has to be constant actually. Therefore, one can use the variable part select in loop actually. In a loop also you can use, this is the for loop statement. You can see for j equal to 0, j less than equal to 31 colon j equal to j plus 1. Now you can see byte is equal to data 1 of j star 8 plus colon 8. What will happen this now? Here this statement within the for loop actually. So now the j is varies from 0 to 31. So now automatically what will happen? First the j will be initialized as 0. So it becomes what? 0 plus colon 8. So then I can say data 1 0 colon 8 in the sense it cannot be 0 colon 7. Because as I said 0 colon 7 will become wrong. Why? Because the data 1 has 255 colon 0 in this phase. So it's supposed to be 7 colon 0. See? First. Second, what will happen? J will be incremented to 1. Now 1 into 8, that is 8. 8 plus colon 8. Automatically next data 15 colon 8. Next will come. Next, like this only, you will get the byte in the for loop. So even we can initialize a part of the vector as like this also we can vector. See, data 1 of byte number into 8 plus colon 8 is equal to 8 dash b dash. If byte number is equal to 1, if this 8 number equal to 1, it's clear 8 bits, that is 15 colon 8, because 8 plus colon 8, that is nothing but what? The 15 bit, that is nothing but the data 1 of, I'll say like this. Data 1 of 15 colon 8. This portion will become as 0 actually. You remember that the size of the data 1 is what? 255 colon 0. It is the length of 256 bit. In the 256 bit, the 15 colon 8, this position, because here we written this data 1 of byte will be assigned to 0. So only those will become as 0. See, that is, so it clears the 8 bit. I hope you might have understood now. Is it clear this one? Next is integer. Now we'll see the integer. You remember in your C programming also you studied the data type. One of the data type is integer. Normally the range of the integer value will be 2 to the, that is a minus 2 to the power, the range. So what is the range will be? Actually the range will be, the range of integer is minus 2 to the power 31 to 2 to the power 31. Just I'm not saying exactly, so approximately I'm saying the range of integer is minus 2 power 31 to 2 to the power 31. So normally the integer will have the both rotation values, that is a positive and negative numbers. So an integer is a general purpose register data type used for manipulating quantities. The integers are declared by the keyword integers. See, the integers are declared by the keyword as integer values in a Verilog. Although it is possible to use register as a general purpose variable, even the register also can be used. So it's a more convenient to declare an integer variable for purpose of countings, especially when you're using the counters. There and all we'll use the integer numbers. The default width of integer is the host machine word size. That is, which is implementation specific at least 30 bit. That is the meaning of. So simple, I can say the default width for an integer is 32 bits. Default width. The register declare as data type register store the values as unsigned quantities. See, as I said, the integer has two values, like the negative as well as positive values. But when you are declaring the integer as a registers, by default it will store as unsigned number actually, whereas the integers normally your register, when you declare register, the data type register store values as unsigned quantities, but when you're using the registers, the stored values as signed quantities. Remember, the registers means unsigned quantity. When you're using the integer, that will store as a signed quantity. The syntax for integer. Integer is a keyword, that is integer followed by integer name. This can be an identifier equal to the range of value. What is the value you are going to give? That is the syntax here. Example for integer. See, the integer counter I given. Now, let me take the initial counter is equal to -1. If I write as -1, automatically the system will consider as it is declared as an integer. If I'm not declare this as integer, then if you give the value as -1, what will happen? The system couldn't be able to store the -1. It won't consider as a -1. It will because the system doesn't know it belongs to which data type. Now this is nothing but a -1 is stored in the counter. Next is real. Which is the real value? The real values are the decimal values, we can say. The example in the C programming is what? Any idea? Example for C program is the real is nothing but in C program. In C programming, that we'll use float. Float is equivalent to real. Float numbers. So the float numbers are example, as you know, it's nothing but what? 3.14. The pi is a float value. Same even here also. The real numbers constant and real number constant and real registered data types are declared with the keyword real. See here, the real numbers constant and real registers data types are declared with the keyword. Keyword we have to use the real. Now you'll see here they can be specified in decimal notation. Example, as I said, the example for real is what? 3.14 or scientific notation 3e6. What is the meaning of 3e6? That is nothing but 3 into 10 to the power of -6. That is nothing but 3e6. Then real numbers cannot have range declaration, very important. But the integer has range declaration, but the real doesn't have the range declaration. That is range declaration, and the default value is 0. For the real, the default value is 0. When a real value is assigned to an integer, remember, sometimes integer can be a real, but integer can be not integer. So real can be integer, but integer cannot be a real normally, because the real number is rounded off to the nearest integer. Example, I will say one of the example is, let me take a simple example. What is that? Let me take example integers. Okay, integer, let me take integers. Numbers are, as I said, -32, 23, 100, minus this a whole. These are the numbers are integers, I can say. Now real, what are the reals? I can say reals are like 3.14, then 3 into 10 to the power of 6, 7, or anything you can say. Now one more thing I'll say, if my real number is 3.14, but you are not declared as a real in the data type. If you are declared as an integer, then this 3.14 will be read as, the value will be rounded. In the sense 3.14 will become as 3.0. Okay, say example 5.5. If I say 5.5 real, when I go for as an integer, that is like nothing but a 6. It will round off the value of the nearest integer. That is what, so it will take like this one. So now next is the syntax for a real is real. The real is a keyword followed by real underscore name. This is I given, this is something with identifier. Then value. What is the value of the real? That you can give. Example, you can see here real delta real delta. So here the delta define a real variable called a delta. Where I will use the delta which has the real value. Example, this is a simple example. Don't think whether it belongs to any program. Just we are giving an example for real, followed by initial, then begin. Delta is equal to 4E10. So nothing but the delta is assigned in scientific notation. The scientific notation in the sense, what is the scientific notation? Simple, we can say scientific notation in the sense it is 4 into, that is 4 into 10 to the power of minus 10. This is the meaning of it. The delta is nothing but 4 into 10 to the power of minus 10. The E is nothing but 10 actually, 10 to the power. Scientific notation. Then delta 2.13. Delta is assigned a value of 2. Now I'll give you an example here. Instead of this real, okay, instead of this real, you don't you leave this one, because I cannot declare this as integers, or even I can declare as integer. 4 into 10 to the power of minus 10 will go as 0.00 some value, then it will become a 0 only. Instead of this, if I declare as integer this portion, instead of this, what will happen? But I assign the value as like this. How it will be read while reading in the program? The delta will be read as 2, not 2.13, because the nearest value is what? 2.2. It won't take 2.3. It's not possible because it has round up the value. So it considers 2. What about this? This value will consider as 0 only. Why? Because 4 into 10 to the power of minus 10. If it is 4 into 10 to the power of 10, means it will complete, will become as integer number. So this is the difference of your integer as far as the delta. Okay. Here we given delta, next end. Initial, begin, end. Now here I given integer I. See, example is one. Integer I, initial I is equal to delta. That is what I said. See, I gets the value of 2. Because the delta value is assigned as 2.13, here I am going to get I equal to delta. The delta value is 2.13, but this I variable is declared as integer. So if it is integer, then that's how it will be. Instead of 2.13, it will be gets the value as 2. This is how we will use in our Verilog. Next, time. The time is one of the very important data type in the Verilog. The Verilog simulation is done with respect to the simulation time, because already as I said, simulation time. What is meant by simulation time as I said? So like at what time, up to which time your simulation will run. That is only something about your simulation time. Here, a special time register data type is used in Verilog to store the simulation time. A special time register data type called as like time. There is a keyword called as time is there. That is a register data type here. A time variable is declared with the keyword time. This is what I said. This is the keyword. The time is a keyword we'll use in a Verilog. The width for time register data type is implementation specific, but at least 64 bits. See, this is by default, I can say. Normally the time, the register data type, the width in the sense, the size of the time will be 64 bit. The system function, normally I cannot say only time. The system function sometimes we are having, that is $time. It's invoked to get the current simulation time. See, when you are running a program for around 100 or 200 time delay, in that you want to get the current simulation time. At that time, if you use the $time, then you will get the current simulation time. Will get like in between. If any event occurs, say example at time 50, the value of A is changes in the sense. If I specify with the $time, so exactly at which time your A value will get changed, so all the values will get with the help of the $time. So later we'll see all these things, how we are getting. Next, the simulation time is measured in terms of simulation seconds. This is what, as I said, means when you are doing the simulation, the system, If you are doing the milliseconds, the simulation time is measured in terms of milliseconds. If you are measuring in terms of picosecond, then it's a picosecond. But the unit will be done as, yes, it is nothing but generally it is seconds, but the same as real time. For example, millisecond, microsecond, picosecond will go up to that. So, however, the relationship between the real time in the digital circuit and the simulation time is left to the user actually for us. So the syntax will be like what? Time. The time is a keyword followed by time underscore name. It's a identifier. This is identifier. Now let us see the example here. Time followed by save underscore sim underscore time. Something but we are defining a time variable as save simulation time. So like how we need to save? Time is a register. You remember the time is a register. We need to save the simulation time. So how it will be? Initial save simulation time. This variable return is equal to $time. So if I specify $time, automatically the system will save the current simulation time. Current simulation time, automatically it will save the current simulation time. That is nothing but the timings. Next is a very important data type in the Verilog, as like you studied in your C programming, it's a arrays. Here normally the array is a collection of variables, as we studied already in C program. Array is a collection of variables, all of the same type and accessed using the same name plus one or more indexes. In your C programming, normally the array will be classified into some three types, I can say, like a single dimension array, that is one dimension array, two-dimension array, and multi-dimensional array. Even here also like that is that one-dimensional array, two-dimensional array, multi-dimensional array. But in the C programming, the arrays are indexed from 0 by integers. You remember that the arrays in your C programs you might have write like this. I will declare the array in a C program. I hope you might have remember. Like in C programming, in C, the array will be like this: A of 3, then B of 3. So this is the array. If I say that's what A has 3 value and B has 3 value, like this only I hope you might have done in a C programming, or not like this also, you might have done like this, A of 3. See, I hope. So now in this, like here are converted to pointers in C programming. Remember, I hope everyone studied the C programming. The arrays are indexed from 0 by integers are converted to pointers. So although the whole array can be initialized, so each element must be read or written separately in the procedural statements. So that is what here we are going to do. Normally in Verilog 2001 model, the arrays are indexed from left bound to right bound. You see, very important here. The arrays are indexed from left bound to right bound. That is from left to right. If they are vectors, because normally array values we need to declare in terms of vectors only. They can be assigned as a single unit, but not if they are arrays. Verilog 2001 allows multiple dimension normally here. So now the one more thing, the arrays are allowed in Verilogs for registers, integer, time, real time, and vector register data types. All these data types can be allowed in a arrays. The multi-dimensional arrays can also be declared with any number of dimensions, like 3 dimension, 4 dimension. You can go any number of dimensions. You can go with the help of multi-dimensional array. Then the array of nets. The sense you remember nets initially we studied, right? The array of nets can also be used to connect port of general instance. Next, each element of the array. So because the array will have n number of elements, in this each element can be used in a same fashion as a scalar or a vector net. Like icon you can use as a scalar value or vector value you can use. Each element of your array you can use. How you can access the array? So arrays are accessed by like this. See, array name, then the subscript, then which indices that you have to specify. That is nothing but an array. For multi-dimensional array, the indexes need to be provided for each dimension. Example, the data underscore type. This is the data type. Then array name you have to give, row value and column value you have to give. This is for multi-dimensional array. And it can be included two-dimension also. So two-dimension will be given as like this. Now let us see how we can use the arrays. Very, very important here. You should not get the confusion in the arrays. That is very, very important. Let us take the module arrays underscore data example. Okay. Now, two-dimensional array of Verilog. How we can declare the two-dimensional array? We can see. Now that is see here two-dimensional array of Verilog. Now register. You remember here data type. The data type is something what register. That is the registered data type. Then followed by array name is required. Correct? Still see how you have to declare the array in Verilog. See, this is the way you have to declare. Register 7:0 memory 0:3. Now you need to understand what is this. You need to understand that is nothing but the memory has 4 elements. That is 0, 1, 2, 3. Remember? The memory has 4 elements. How it will be in the sense? Let me show. You may think it will be very, very easy. See, I show this. This is the array. Okay. This is the array. This is the nothing but your memory. This is something but your mem. Consider this is your mem. So now how many elements? 0:3. Totally 4 elements as that. 0, 1, 2, 3. Element you see 0. Indices. This is indices 0, 1, 2, 3. See 0, 1, 2. These are called as indices. Now each and every element. This is the element actually. Correct? Each and every element the size is 7:0. That is 8-bit. So this will be 8-bit. I hope now you understood. Simple register of 7:0, mem of 0:3 in the sense this is a memory declaration. Memory, how many elements? Totally 4 elements. Each element, the size of each element is 8-bit. So this is 8-bit. This also 8-bit, this also 8-bit, this also 8-bit. Like this it be stored. So what are the values in the sense? Here I given. See this? We given like this. This is nothing but indices transpose. The sense it because your indices will come like this. 0, 1, 2, 3. But you should not say 0, 1, 2, 3. So it has to come in this way. We cannot write like this. That is the reason we given us the dash symbol. That is called as indices. Now, how it is stored now? This is stored as like this. First value will be 0, second is 1, third is 2, this is 3. These are the values are like 8-bit values. 0, 8-bit value, this is 8-bit value, this is also 8-bit value, this is also 8-bit. This is something with the memory, two-dimensional memory array.